Hi, welcome back to this video. In this situation, we are going to be doing some chemistry, particularly chemistry in grade 12. And in this particular video, we want to look at pH calculations. So we are going to be given some type of results that can come from a reaction. It could be an acid or base, and we want to see the result that we get at the end. Okay, so here is the question that we are going to be considering here. What is the pH, right, of a 1 times 10 to the negative 2 mole per cubic decimeter, DM3 solution, but this is going to be for a particular acid, HCN, right? And this HCN, we are told that the result that we have is that we have a Ka result, and this Ka is going to be 4.0 times 10 to the negative 10. So these are the information, this is the information that we have or are given, and we have to use this information to see to it that we find the solution relevant to this particular problem that we have. So we have an equation that we can actually use in this scenario, and this is the equation for this Ka, or this acid dissociation constant, that is that Ka that we have. So the answer that we're going to look at, first of all, we have to consider the reaction and how this reaction process proceeds as we have in time, right? So we know that it's an acid, so an acid ionizes with water, so we have to have some H2O, so we have some HCN, which is our acid, and this reacts in water to ionize, so we have some H2O. And then the products from this particular reaction are going to be some H3O, because an acid is a proton donor, so it gives off an ion and an H plus to this H2O, giving us H3O plus. Then we'll be left here with a Cn minus, so that would be plus a Cn minus. Okay, now that we have this scenario here, we can see that on this left hand side, that's where we've got our HCN, but we are told the concentration of this particular HCN, and so we have this HCN in terms of its concentration is going to be given by 1 times 10 to the negative 2 mole per cubic decimeter, so DM3. But we also see that this reaction is a 1:1 reaction, so we've got 1 there, and we also have a 1 and a 1 over there. Okay, so because of this, we know that we are particularly interested, of course, in the concentrations that also then result at the end of the day. So we can say, let us call this sum X concentration. Let's call that sum X concentration, because it's a 1:1 reaction that we get here. And because of this, we can go and say, from the Ka value that we have, we can say then that Ka is equal to, first of all, the concentration of the H3O plus and the concentration of the Cn minus, all that divided by what we had at the beginning, and at the beginning we had HCN. Okay, so this is the same as just having x squared that we had over there, right, divided by 1 times 10 to the negative 2 mole per cubic decimeter, so MOL divided by DM3. Okay, and we know that this is then going to be given by this particular value. We already know what the Ka value is, so we can have just simply 4, right, times 10 to the negative 10, which is our Ka value, and we see we have an x squared on this particular side of the equation, and having that, we can also see that this is then divided by 1 times 10 to the negative 2, so 1 times 10 to the negative 2. And of course, we can solve for x. So we have to have in this situation that we have our x there. X squared equals to going to be equal to 4 times 10 to the negative 10. Let me just get my calculator so we can calculate this. This is going to be times 1 times 10 to the negative 2. And so once we have this particular result, we can then calculate this to see, maybe before we do that, we can just take the square root of everything. We then find that we have got an x is going to be equal to the root of this whole result. And so when we do this, it's going to be 4 times 10 to the negative 10 all that multiplied by 1 times 10 to the negative 2. So let me do that on my calculator. 4 times 10 to the negative 10 multiplied by 1 times 10 to the negative 2. And this result gives us 1 over a huge number, which can simply be written in scientific notation as 2.00 times 10 to the negative 6. So we have a concentration, and this concentration happens to also be the concentration of H3O. So we can then say that X is equal to the concentration of H3O plus. And this is then 2 times 10, 2.00 rather, 00 times 10 to the negative 6, right, cubic per decimeter, so mole cubic decimeter. All right, now that we have this, we know that for us to calculate the pH of an acid, we have an equation that we can use for that. It's going to be pH is going to be, so here that's when we start using the logarithms to calculate the pH of this particular situation. So it's going to be the negative log. So pH is going to be the negative log of this concentration. So the concentration in this case was 2.00 times 10 to the negative 6, right? And once you punch that into an answer, we have negative log of that particular answer, and the final result we get is going to be equal to 5.0. So let me put that in without scientific notation. The answer is going to be 5.69 or 5.698, so 699, which is the same as just saying 5.7. So the pH in this situation is definitely going to be 5.7. So pH of this scenario is going to be 5.7. And this happens to be the answer or the solution that one has to arrive at if one is dealing with this particular answer. Perhaps one might just round this answer up, right? So if you want to write it as a single answer, you can just have this simply being equal to, or approximately just equal to 6. And so this would be the final result if you wanted to have one significant figure. So that concludes that particular question.